Hello everyone and welcome to today's Physics Daily Booster. This is number 6 in our series and it is one of the advanced information listed topics for those of you doing the higher tier physics. Not explicitly listed for the foundation tier, but as always doesn't mean that the topic won't come. What we're going to be doing today then is having a look at Newton's first law. Now Newton's first law quite simply states that an object will continue to stay at rest or move with a uniform velocity unless a force acts on it. So by that we mean if an object is stationary, it will remain stationary unless a force acts on it, and if an object is moving at a constant velocity, it will continue to do so unless a force acts on it. So there has to be some kind of a force acting on this object to change its motion. Now, hopefully we do remember velocity is a vector, therefore it has a magnitude and a direction. So therefore we could see a change in speed or a change in direction of the object in order to change the velocity. Now, in order to do that, we need a resultant force. If we consider our resultant force then, if the resultant force is 0, then the speed or the direction will not change. Because if the resultant force is 0, then there is no overall force in a given direction. Therefore, it will just continue doing what it was beforehand. And what we're really going to consider then when we're working out, is this actually going to have an effect on an object or not, is this idea of inertia. Now, inertia quite simply is a measure of how difficult it is to change an object's velocity. So realistically, when we're talking about Newton's first law of motion, it's all about inertia. Now, if we're actually talking about an object that is moving, and it's moving at that constant velocity, if obviously the velocity does not change, then the resultant force must be 0 again. So anything that's moving at that steady velocity, that sort of constant velocity, then the resultant force is 0. Now, what we could also do is use another word to describe this, and the word is equilibrium. Because if something is at equilibrium, that means that the forces all cancel each other out. So our resultant force is 0 once more. If we have a little look at what that would look like in terms of our free body diagrams on the right there, we can see the arrows are the same size but in opposite directions. So because the arrows are the same size, then our resultant force would be 0 in both of these cases. Now that means that if obviously it was something that was stationary, it would stay stationary. If it was moving, it would continue moving at whatever velocity it had before. If our resultant force is not 0, then what we're going to see are potentially a couple of different effects. Firstly, we could change the speed of the object, so how fast it's moving could be altered. Because we're talking velocity, we could also see a change in direction of the object. Or we could see a change in both speed and direction. So either speed or direction, or both speed and direction may change if that resultant force is not 0. So what we're really saying is, if the resultant force is not 0, the object is accelerating. And when we use that word accelerating, that can refer to either the change in speed or the change in direction. So don't forget that things that change direction there would also be described as accelerating. We come on to this whole idea of Newton's second law then. Now, Newton's second law just states that the acceleration the resultant force produces is going to depend on two things. Firstly, the size of the resultant force, and secondly, the mass of the object. So Newton's first law is that things just continue to stay stationary or move at that constant velocity unless a resultant force acts on them. Newton's second law tells us that the acceleration we generate as a result of that resultant force depends on the size of it and the mass of the object. This brings us very nicely onto our next little bit, which is a calculation. Now, as we know, we don't have to learn any of these formulas this year. This is going to be on the formula sheet that you are given. Force is mass times acceleration. Key bit to note, mass is in kilograms. So check the question. As soon as you see a mass given to you in grams, then what we need to do is divide that by 1,000 to get it into kilograms. First thing always, never use the mass in grams to do this, otherwise you're not going to get the right answer. So always check if a mass is in grams, divide by 1,000 to get the kilograms. Then you can substitute into our formula. One of the practicals that they have listed as one that will be assessed on both foundation and higher are the practicals to do with speed and acceleration. So this is one of those bits we're going to have a little look at now, just a couple of those points that could come up here. What we can do in order to investigate the acceleration of a little trolley, so here is our little wooden trolley. And if we want to know how it accelerates, what we do is we attach basically a string onto the end of it, which goes over a little pulley system, and then we can attach the masses at the bottom here. So down here, those are masses. So what we can do is obviously change the mass, see what effect it has on the acceleration. Now, a couple of points here. First of all, if we're doing this and using a stopwatch to time, we have a potential source of error, because as humans, obviously we have a reaction time. So when we're doing this, our reaction time could lead to slightly inaccurate times being recorded. That could be a problem. If they then ask us to suggest an improvement, the answer is use light gates. Because light gates, quite simply, we'd attach a little bit of cardboard onto here, and then as it passes through, it's going to break the beam on the light gate, starts the timer, and then as it passes through a second one further down, again, it will stop the timer. So that removes the human error side of things. The other bit we need to consider is that we've got to compensate for friction, because if we literally just put the trolley flat on the desk, then friction is going to be a factor here. So how do we do this? Well, we raise the ramp very gently until the trolley moves down at a steady speed. So what we're going to do is find the trolley's moving at steady speed, at which point we've compensated for friction. The last little bit that we're going to look at today then is the idea of something moving in a circular path. So think about, you've got, I don't know, the sort of typical experiment that you might have seen is a bucket on a string. As you spin it around, then it just moves in this circular motion. Now, when the object is moving around in that circular pathway, what it's doing is it's going to be travelling, hopefully, at a constant speed. However, it could still be classed as accelerating, not because the speed is changing, but because the direction is changing. And remember what we said earlier, acceleration is a change in speed or a change in direction. Here, our object is constantly having these little changes in direction to keep it in a circular pathway. Therefore, direction is constantly changing, it is accelerating, even if it's travelling at the exact same speed all the way around. Because speed, remember, is just a scalar quantity, so it doesn't have direction. Do remember that in order to allow any object to travel in that circular pathway, we need a force directed to the centre of the circle acting on that object. And this is something that's obviously going to pop back into our knowledge when we come on to that final topic of P8 and we look at things like the orbits that planets have in our solar system. Final thing to do for today then is head on over and have a go at the quiz, see how well you've understood the bits we've done today. Obviously, if there are little bits that you'd rather spend a little bit longer looking at, you've got the main videos on the channel that you could use, your revision guides, your notes, and as always, I do recommend that you have a look at some past papers just to get a bit of a feel of the kind of questions that have come up. Even if you don't physically write down all of the answers, sometimes just sitting there, go through the multiple choice section, just answer those 15 questions very quickly in your head, check the mark scheme, see how you're doing. And don't forget to join us again tomorrow for our next Physics Daily Booster.